Okay, so now let's look at this problem. Find the volume of the solids generated by revolving the region between y equals 2 square root of x and y equals x squared over 4 here. First of all, as you can see, this is a graph. Okay, so y equals 2 square root of x is just the upper part. We need first to find the intersection point, meaning we have to solve both. Okay, so that is x squared over 4 equals 2 square root of x, and if we square both sides, that will give us x to the power 4 over 16 equals 4x. Okay, equals 4x here. And turns out that, as you can see, you're going to have x to the power 4 equals 16 times 4 give us 64, right? X. So if we factor x out, and you can solve that x equals ISS 0 right here, or x equals cubic root of 64, which is 4. So this one, we got it. So x is 4, so, and then square root of x is 2 times 2 is also 4. Okay, so that's the point. Once we got that, things become very straightforward. So we can use the Washer method, right? If we're gonna do the region, revolving the region about the x-axis, let's do about x-axis, and you can see that basically we're gonna have something like this, right? And noticing that if we draw a cross section, very bad drawing, okay guys, as you can see that. So the upper function is going to be 2 square root of x, the lower function is going to be x squared over 4. So our capital radius, which is the upper function, is 2 square root of x, and the lower function is x squared over 4, and hence the area of this washer is going to be pi times capital R squared minus pi times small r squared, right? So that gives us is pi times, this part is going to be 4x, and minus x to the power of 4 over 16, right? So that's the area of this washer. Now the volume is going to be integrated from 0 to 4 pi times 4x minus x to the power of 16, 4 over 16 dx. Okay, and it's pretty easy to evaluate it, believe it or not. So we can factor pi out. You can have 2x squared minus x to the power of 5th over 16 times 5, right? And then evaluate it from 0 to 4. Okay, from 0 to 4. And it turns out that you can have 2 times 4 squared is 16 minus 4 to the power of 5th over 16 times 5. And then turns out this is going to be pi times 32 minus this part is you're going to have it's a 64 over 5. Okay. And if you let them have the same denominator, which is 5 over 160, and then minus 64, turns out you're going to have 96 over 5 pi. Okay, so that's how do we handle in this way. If we try to do revolving about the y-axis, okay, so I can set it up, and then you can solve this integral by yourself. If it's about the y-axis, noticing that we can still do the Washer method, but the cross section, as you can see, is going to be something like this, right? So, and then our y going to be from 0 to 4, okay, from 0 to 4. So, so the capital R, differently with revolving about the x-axis, you need to solve the capital radius in terms of the y. So since you can see that this time the outer radius here, which is going to be y equals x squared over 4 here. So actually we need to solve x in terms of y. So solve for that. So let me put it here. Y equals x squared over 4. If we solve x in terms of y, that's going to give us is 4y equals x squared. X equals, we only take the positive one, okay, part, so it's going to become just square root of 4y. Okay, so that's our capital R. Our smaller r is going to be this part. So our smaller r, we're going to solve y equals 2x, solve x in terms of y. As you can see, that will give us is y over 2 equals square root of x, and then x equals y squared over 4. So that's give us is a y squared over 4 here. Okay. So you got the capital R, you got as little r here. So the area of the washer is going to be pi times capital R squared minus small r squared, right? And hence, you can set up the integral as from 0 to 4. Right now, we are handling with respect to y. So it's a pi times our capital R is square root of 4y. So square root of 4y squared minus y squared over 4, then square, right? And then dy. I believe the solving this integral should be pretty straightforward, okay? So you can finish that by yourself. But as you know that this is the basic structure of how to solve this type of question, okay? So yeah, so I'll stop here and thank you for watching.